Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Natasha, and the technical issue related to engineering practice that I'm going to share is misrepresenting of technical accuracy. And the topic covered for the slide is the identification of problem, example of ethical issue, the solution, and lastly is the conclusion. Okay, so technical accuracy refers to the degree to which information, data, or work aligns with established standard, formulas, or accepted reference values. As accuracy ensures clarity, reliability, and precision, preventing misinterpretation and errors. In vocational education, especially during community service projects, we often use simplified construction models to teach technical concepts. However, these models have limitations as they don't fully demonstrate the safety, material behavior, or lab performance that can lead to misunderstanding real construction practice, which poses ethical risks. Okay, so for example, when engineers design a reinforcement beam, they must calculate the exact amount, the sizing, and the placement of the steel reinforcement bar to resist the bending and shear force, as it may lead to crack under the load or even failure. In addressing the ethical challenge that we have identified, we must prioritize three principles, which is truthful communication, prevention of deceptive practice, and the protection of public safety. As an engineer and instructor, it's our responsibility to clearly distinguish between conceptual learning tools and actual engineering practice by stating the assumption, limitation, safety consideration, and regulatory requirement involved. By doing so, we align our action with the PM Code of Professional Conduct and the Engineers Act 1967, ensuring that our service to the community is not only educational but also ethically sound and professionally responsible. As a conclusion, in both educational and real-world construction contexts, technical accuracy is not just a matter of precision, but it is a matter of public safety and professional integrity. According to the Board of Engineers Malaysia, failing to clarify this limitation may breach professional conduct. To uphold engineering ethics, we must ensure all demonstrations are technically accurate, transparent, and clearly framed within their educational purpose, not only to protect public welfare, but also foster a culture of responsible engineering practice. That's all for me. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shahida binti Abdul Hamid, and I will be presenting an ethical issue in civil engineering practice, which is inadequate maintenance and delay repairs. This issue focuses on situations where early signs of structural problems are identified, but corrective actions are delayed. In civil engineering, ethical issues arise when early weaknesses such as low bonding, uneven support, or minor surface distress are detected but not addressed immediately. Although this issue may seem minor at first, delaying actions can significantly affect structural performance and safety. This reflects how delayed decisions occur in real engineering practice. From an ethical perspective, failing to take actions after identifying defects is a violation of professional responsibility. Civil engineers are expected to apply due care, responsibility, and also sound engineering judgment. Ignoring obvious weaknesses goes against ethical engineering principles, as engineers are trusted to ensure that structures remain safe, reliable, and also functional. If early-stage deficiencies are deliberately ignored or corrective measures are delayed without justifications, this can lead to professional negligence. This negligence is usually caused by poor judgment rather than lack of technical knowledge. The consequences may include early structural failure, higher maintenance costs, and also reduced service ability. So, to overcome this issue, engineers should carry out systematic inspection and early intervention from the beginning of a project. Any identified defects should be corrected immediately to prevent further failure. In addition, strengthening ethical awareness among engineers with different levels of experience helps to improve judgment and also reduce negligence. So, in conclusion, timely maintenance and corrective actions are ethical obligations in civil engineering. Proactive decision making protects public safety, maintains structural performance, and also upholds professional integrity. Thank you.
Assalamualaikum everyone. I am Adik Fitri Basharul from Group 6. Today, I will be presenting about one of the ethical problem of a civil engineer, titled Poor Drainage Design and Maintenance. Within the master project, we identify the neglects of drainage performance during construction as a critical ethical issue. This is a novel ethical problem because poor drainage leads to predictable yet preventable pavement failures and flash floods that endanger the community. From a professional standpoint, failing to manage water runoff is a breach of the professional accountability we owe to the public. According to the Registration of Engineers Act 1967, allowing such substandard design to proceed is a direct failure in our commitment to public safety. To address this, we must strictly apply the BEM Code of Professional Conduct 2016, which mandates placing public safety and welfare above all other interests. Applying the principle of professional integrity, it is ethically imperative to ensure drainage systems effectively divert water to prevent pavement saturation. Because stagnant water is the primary cause of potholes and structural weakening, we must adhere to national technical norms to ensure infrastructure longevity. This commitment requires us to reject any design that compromises the road's durability, fulfilling the social contract defined by IEM regulations. Professional misconduct in this field often appears as negligent certification, where an engineer signs off on inadequate plans or gross negligence in maintaining drainage assets. To overcome this, I propose the inclusive road drainage framework. This solution uses mandatory peer review audits to prevent errors. Crucially, we address diversity by using hill-safe drainage grids and smooth pavement transition. This ensures that our roads are safe for everyone, especially senior citizens and wheelchair users who are most vulnerable to slippery hazard and road damage. Prioritizing physical ability shows an inclusive attitude and respect for all members of society. In conclusion, as civil engineers, we must uphold the social contract with our community. By strictly adhering to the BAM Code of Conduct and REA 1967, we prevent gross negligence and prioritize public safety over convenience. The Mistral project demonstrates that inclusive attitudes, specifically designing for senior citizens and wheelchair users, are fundamental to professional practice. Ultimately, ethical engineering is inclusive engineering that serves every member of society equitably. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Anas and today I'm going to present about a huge ethical problem in our industry, the falsification of test results in road maintenance. So here's the issue. To save money or speed up approval, some engineers intentionally fake site data, usually asphalt compaction rates or pavement thickness. But let's be real, this is not just cutting corners. Under the Registration of Engineers Act 1967, this is fraud. It's a choice to put profit above public safety. The consequences for this are actually huge. Ethically, this is a direct breach of the public trust and violates the BEM Code of Professional Conduct. Legally, it breaks three major laws. First, Section 15(1) of the REA, you can get deregistered. Basically, your career is over. Second, Regulation 24, it violates our strict duty of honor. 3. MACC Act 2009, you can actually be charged with corruption for certifying false results. So, how do we fix it? I'm proposing an independent digital audit system, IDAS. This system uses tamper-proof cloud logging. The moment test data is recorded on site, it's logged in the cloud. No engineer can go back and change the numbers later. It completely kills the opportunity to cheat. And this is why it matters for inclusivity. When engineers feed data, roads fail and potholes form. For most of us, that's just annoying. But the wheelchair users or the elderly, a bad road surface is a dangerous physical barrier. By using this system to guarantee the road is built right, we ensure it's safe for everyone. protecting the most vulnerable people in our community. In conclusion, falsifying result is a serious act of fraud. We need to use technology to enforce honesty and ensure our infrastructure is safe for all. Thank you.
Hello and Assalamualaikum. My name is Muhammad Ali Farhan bin Muhammad Hashim Ko, and today I will present about ethical issue in engineering practice related to the misuse of construction practices, specifically involving incorrect material proportions. This issue is highlighted through the mini stem kit batu bata implemented under the master program, which serve as an educational tool to demonstrate the importance of proper construction practices and also ethical responsibility in engineering. The key ethical issue identified is the improper control of material proportions in brick and cement works, particularly the water-cement ratio, poor batching, inadequate mixing techniques, and also insufficient site supervision often result in weak bonding and reduced structural strength. Through the mini stem kit batu bata, although the bonding mix used wasn't a cement, which is flour mixing, it can be clearly observed that incorrect proportions lead to a premature cracking and also early failure of brick samples, closely reflect in the defects commonly found in real-world infrastructure projects. Therefore, such improper practices have serious implications for the community and society. Structures with poor material proportions experience reduced durability and a shorter service lifespan, which leading to a frequent repair works and increase the overall maintenance costs. More importantly, these failures pose safety risks to the public and also place additional financial burdens on government authorities and taxpayers. These outcomes demonstrate professional negligence and highlight the critical role of engineers in safeguarding public safety and also infrastructure performance. From an ethical and professional standpoint, engineers are required to comply with established standards and regulations, including the UBBL, MSCN standards, and also JKR specifications. Failure to adhere to these requirements constitutes professional misconduct under the Registration of Engineers Act 1967 and violates the BM Code of Professional Conduct. Engineers are ethically bound to act competently, responsibly, and in the best interest of the public at all times. Hence, to address this ethical issue, firstly, strict enforcement of mixed design control is essential. Material proportions should be based on approved mixed designs prepared or verified by a BEM registered professional engineer, and any modifications must be properly documented. In addition, on-site quality assurance measures such as routine inspection, material testing, and also independent audits should be consistently implemented to prevent non-compliance and construction defects. In conclusion, the mini STEM kit batu bata plays a significant role in enhancing ethical awareness by providing hands-on learning experience that demonstrate the consequences of poor construction practices. Correct material proportioning is not merely a technical requirement but a fundamental ethical obligation of engineers to ensure public safety, maintain professional integrity, and also deliver sustainable and reliable infrastructure. So, before I end my speech, I would like to end with a quote from Bret Hart. If you've got the confidence and the work ethic, you can make any dream come true. So that's all from us. Thank you. Bye. Assalamualaikum.